In this lecture, we're going to look at constant expressions. A constant expression is something that is going to be evaluated at compile time. And let's take a look at this slide here. In our C++ development workflow, we type things in the IDE when we are designing our application. We declare variables, we do all kinds of crazy things. And when we want to generate a binary for our program, we're going to pass that through the compiler, and we're going to get an executable that we can then run to get it to do things. So we can really divide this workflow in three parts. We have the IDE time, when we are in the IDE typing things out. We have our compile time, when the compiler is working hard to generate a binary for our program. And we have the runtime, which starts when somebody clicks on your binary to run it and get it to do things, or runs it through the terminal like we have been doing for Rooster in this course here. So make sure you understand the differences between these times. Constant expressions are evaluated when your application is being compiled, and the result of these expressions is going to be stored in the binary and reused whenever that binary is executed by somebody. So we can take some heavy computations and move them at compile time. And that's really the big idea here. And we use the keyword constexpr to say that the computation is going to be done at compile time. So constexpr means that whatever it is you are declaring or initializing may be evaluated at compile time. Okay, with constant expressions, if possible, we can move the heavy computations at compile time, and we're going to save the result in our binary, and every time the application starts up, we're going to reuse the results without actually going and redoing the computation. And this is really cool, and it can save a lot of time in some applications. So let's visualize this here. We have our simple program. We have the main function. We are printing hello C++20. We can compile it and have an executable binary. When somebody runs this binary, and they are going to do a computation, that is possible to be done at compile time. But if we don't do it at compile time, it is going to be done every time somebody runs this binary. This is what we mean here. We're going to initialize our application. We're going to run the potentially constexpr computations, and then we're going to do our runtime computation. And this can be bad because everybody who uses your application is going to pay the price for this computation. And it may be a heavy computation that is going to take a lot of precious CPU cycles from your program. So to optimize on this, we can move these computations at compile time. And here is another version of the compilation of our program. Now we have taken these ready computations and moved them at compile time. And the results of these computations are going to be baked into our executable binary. Now, when somebody runs this executable binary file, we're not going to do the heavy computation again. We're going to use the results, and everything is going to go pretty fast. And if the application is run multiple times, we don't pay the penalty. So compile time computations are really moving the penalty to the developer. The user of your application doesn't pay the price when they run the application. You, the developer, pay the price when you are compiling your application. So this is the gist of what compile time programming is really about. And we mean that we are doing compile time programming using the constexpr keyword in C++. Compile time computations were introduced in C++ 11. And with each new version of C++, we are increasing the number of things we can do at compile time. And we can expect this trend to go on with every new major version of C++. We're going to get new things we can do at compile time. So we have talked about constexpr and compile time computations, but how do we use this in code? Here is a simple example. We have an integer called iCount, and we can make it clear that this may be evaluated at compile time by inserting the constexpr keyword in front of this. And this does two things. This is going to flag this iCount variable as constant. So constexpr implies constant, And if you flag something constExpr, it's also going to become a constant. Another thing is that this thing is going to be evaluated at compile time, and the result is going to be stored in this iCount variable here. We have another example for a double variable called pi, and if we print this out, we're going to see whatever is in there. Down here we have another example. We have leg count. It is non-constExpr, and if we try to use that to initialize a constExpr variable, we're going to get a compiler error, because we are trying to do a compile time computation with a runtime value. And again, if you think about it, by the time we hit this leg count, we're going to be in the main function and our program is already running. So we can't use a runtime result to initialize a compile time variable. This is really what we mean here. And we have a few other variables as examples. We have room count. We can initialize this with a literal integer. We can use a constExpr to initialize another constExpr, and we can use this in computations, for example, and we can use constant variables to initialize constExpr variables. And constant expressions are really good if you want to do some checks at compile time. Static assert is a construct we have in C++ that allows us to check for things at compile time. For example, we can say, let's check and see if the I count is 2, and if it's not, we're going to get a compiler error. So if you want to do that, you can insert this line somewhere in your code, and when you try to compile the application and this test fails, you're going to get a compiler error. This is what we mean here. Okay, again, constant expressions are also constants, so you can't really reassign value to them, and if you do that, you're going to get a compiler error. Okay, so this is really all there is to the introduction of constant expressions. We will have a lot to say about this, especially when we get to talk about functions, because functions can also be flagged as constExpr, but we're going to talk about when we get there. For now, let's go to Visual Studio Code and actually play with us. Okay, here we are in our working directory. We are going to go in our chapter. We're going to go in our template project. We're going to copy the files. And the lecture we are working on is constant expressions. So we're going to go in and paste in the code and open this up in Visual Studio Code. And we're going to open our main CPP file. The first thing we're going to look at is how you can declare constExpr variable. And this is how you do it. You just add the constExpr keyword in front, and this is going to flag this as something that can be evaluated at compile time. And because we are initializing this with a literal, this is going to work. This is going to be done at compile time. And by the time we run our binary, this data is going to be already baked into our binary. We can't really see this because compilers aren't really good in showing you things that can run at compile time. So if we build this, it's going to be like what we've been doing before. So let's open a terminal window here and run our Rooster app here. And we're going to see that I count is 2 and pi is 3.14. But if you put a constExpr in front, this is also going to flag your variables as constants. So for example, if we try to set I count to 3 here or 4, and we try to build, we build with GCC, we're going to get a compiler error. We are trying to assign to a read-only variable because constExpr implies const. Okay, this is something you need to be aware of. Now, if we comment this out and try to build again, the build is going to go through. We're going to build successfully, and if we run this, we're going to get our result. Another thing I want you to see is that you can't take a runtime variable and use that to initialize a constExpr variable. And that really makes sense. You can't use something that will be known when your application runs to initialize something that should be known when your application is being compiled. So if you're trying to do this, you're going to get a compiler error. So let's build and see this. We're going to get an error, and you see the error is int leg count is not const. The basic idea is that you should really use constants to initialize your constExpr variables. For example, if we make this const and build again, The build is going to go through, and we can print this out if we want. But if it is not const, you're going to get an error. And this is something I want you to be aware of. Let's comment this out so that you have this as a reference in your code. You can use constExpr variables to initialize constExpr variables. So here we have a room count variable. It is constExpr. We can use this to initialize another variable called door count. This is going to work. We can also grab a simple const and use it to initialize a constExpr variable. If we compile this, this is going to work, and you can print this out if you want, but I am not going to go through that trouble. You know how to do that. But what I am going to show you is how you can do compile time checks. And what I mean by that is, for example, if your application depends on some variable having a given value, you can check for these things at compile time. For example, if our application requires a given version of a given library, and if we don't have that library, things are going to fail, we can check for that particular version at compile time. And the way you do that, you can say static assert, and you're going to check and see if some measure library version equals 123. You can do this kind of check. Okay, and if you put this line somewhere in your code and the test here fails, your application is not going to compile. Let's put an stdcout statement here just to make sure that we know when the application keeps working. So what do you think we'll get when we compile this program? The test here is going to succeed because the value in there is actually 123. So our program is going to work, and we're going to see this printed out after all the things we've done here. So let's build. We're going to build with GCC. And if we run the application, we're going to see app doing its thing. This is fine. But if we change the version to 1237, for example, and you see that Visual Studio Code is smart enough to notice that something is wrong. It's going to say static assertion failed. It's even going to give you the line number of the offending statement here. So you see, we have a failed static assert, and this is a good thing. If you wanted to check for this, you can catch this error even before you compile the application, and this is good. But even if you ignore this problem at the level of the IDE and build this, you're going to get a compiler error, and the compiler error is basically going to say the same thing. It's going to say error at line 30, column 43. I don't know why it's giving 43 as the column, but it is going to say static assertion failed, and it's going to give you the exact same thing that failed. So this is how you can do some compile time checks on your program, and this will come in handy at many occasions in your career as a C++ developer. One thing that should be really clear is that you can't use things that are not constant expressions in here. So for example, you can't declare a variable, let's say int age, why not, and say 5, for example, and do a static assert and say age equals 5. Okay, so if you do this, you're going to get an error, and let's try to build this so that you can see this error for yourself. And the error is going to say age is not const. So what you can really have inside the static assert is a constant expression, something that is known at compile time, because static assert is a compile time check. It is a check you do when your application is being compiled. So you can't really use a runtime variable like the age at compile time, and this is what is meant here. The errors sometimes won't be very descriptive, and you will have to use your intuition, and your intuition will get better as you do these things many times. This is really all we set out to do in this lecture. I hope you have a better idea of what a constExpr is. It is something that should be evaluated at compile time. This is really not true, and we're going to see more about that when we get to learn about functions. But for now, you can think of constExpr as something that should be evaluated at compile time. We are going to stop here in this lecture. In the next one, we're going to learn about const init.